My name's Dan. Been using FreeBSD since about 95. Hi, Dan. I have about 100 terabytes of ZFS storage in my basement. It's all in use, mostly for backups. I have a lot to thank this guy for that, so he'll tell you more about that.
This mic, okay. My name is Paweł. You may know me as PJD. So I also use ZFS. So I'm happy that it's in FreeBSD as well. We use ZFS in our products. I use ZFS for my own use, and I've been very happy with it.
You could mention that you did the original port.
Yes, I forgot.
It's all your fault. No, it was like 3 weeks, right? 20-ish days? No, it took 20 days.
That's a weekend. 10 days for the prototype.
So I am Alexander, I'm FreeBSD committer, and for
This one.
for hello?
Oh, no.
It's just that. Sorry.
There you go.
Hello. Oh, okay. So I am Alexander Motin, and for last several years as FreeBSD committer, I am trying to pull news and best ZFS updates from upstream, fix some bugs found locally, and sometimes upstream when there is something, and using actively ZFS as part of FreeNAS and TrueNAS appliances of file systems, which also puts significant demands on quality, performance, and nowadays we have significant efforts on the performance side of ZFS, doing a lot of benchmarking, tuning, and trying to make it better and better.
My name's Alan Jude. I've been a FreeBSD developer for 4 years now. Doing a lot of stuff with ZFS and co-authored the ZFS books with this guy, Michael Lucas.
Hi, my name is Michael Lucas, and first of all, it's ZFS, not ZFS. Yeah. And second, ZFS is the absolute worst, except for everything else.
Right.
I don't have anything. It was crap. Okay. So we'll probably mostly take questions. So do people have questions? Nick?
You need a mic.
I don't think there's any more mics. We're using all the mics.
So I have not been paying much attention since BSD can. What's the status of some of the cool stuff like separate metadata devices and D-rate?
Right. So ZFS allocation classes, which is a new VDEV type that's literally called special, and you can set so that you can.
Both mics.
Yes, both mics. So with the metadata or the allocation classes code for ZFS, you would be able to have a dedicated SSD just for metadata, and then write the regular data to your regular disk, or have an SSD dedicated to dedupe, and one other thing it does, right? Or you can also say all blocks that are only are under 16 kilobytes go to the special VDEV, and all the bigger blocks go to your regular VDEVs. That's just about to land in Linux.
I think it's landed very.
It's landed in head, but it's not in a release on Linux yet.
Yeah, I think we just reached head a few days ago.
Yeah, it's like within the last week it made it into the master branch of ZFS on Linux, and so at some point, hopefully not too far from now, it'll be available on FreeBSD. And in particular, that one is interesting when combined with what I've been working on and presented at the ZFS Developer Summit, which is VDEV properties. Being able to set properties on individual VDEVs to express configuration. Things like, for those special VDEVs, what do I want that class to hold? Currently, the configuration is kind of all or nothing. Instead of saying, I want this VDEV for all my 8K allocations and this VDEV for all the other ones or whatever. Or eventually maybe even being able to do tiered storage by saying, this VDEV is made of SSDs, so that's tier 2, and this one's made of hard drives, so that's tier 3. And then the NVMe is tier 1 or whatever, and being able to say, for this data set, prefer allocations from tier X of storage so that your database runs off SSDs, but the logs for the database go on hard drives, but you do this all in one pool instead of separate pools. Or I have a mirror, but the second drive or the third drive in the mirror is actually an iSCSI target from a machine hundreds of milliseconds away maybe, or something, or tens of milliseconds away. So while we want to do all the writes to it, don't bother trying to do reads from it. Read from one of the other mirrors, unless it's the only one left or whatever. So read by us, and any other configuration like that where you'd actually want to do it on a per VDEV basis, or even a per pool. And trying to make more of the tunables, like sysctls, that make sense that way, QDEFs and things like that, be per VDEV instead of just system-wide. Do you know anything about DRAID?
No.
Yeah.
I don't.
DRAID was being worked on at Intel under a contract. They did as much as they're going to do on that. It's open source, but it's not finished.
Tell us why it's nice to have a separate VDEV for metadata.
The original design was they had very large blocks, like they were using the maximum 16 megabyte block for data. But every time you write data, you write some metadata. But the metadata is 4 kilobytes. So if you're writing big block, small block, big block, small block, it just fragments a lot worse. And oftentimes you need the metadata, but you don't always need the data. Right? If you want to do a directory listing or something, or check if a file is modified, that's the metadata. But you don't necessarily have to read the entire file to be able to do that. And
you want to delete something large, or do it on map when you need just to read all the indirect blocks, update them possibly, but you don't need the data.
yeah, there are cases where you need the metadata and not the data. And in those cases, it being faster is better. And because metadata is small enough, you can afford to put all the metadata on SSDs where you can afford to have just an all SSD pool.
Cool.
Yeah. What other interesting stuff was at the Dev Summit?
Putting my metadata on an SSD would mean my LS minus LT would be faster?
Yes.
Good, because sometimes it takes like 3 or 4 seconds for that to come back.
Yeah.
The first one on that directory, yeah, because there's 50,000 files in that.
Yeah, so especially operations like that that are metadata intensive, having that on faster storage, and you didn't actually read any of the files, so you didn't need that data, just the metadata.
And the first one takes a while because it's caching it.
Yeah, on the successive times, it's already in the arc, and so it's really fast. Yeah,
Faster.
much faster. And the same idea for tiered storage, where you're going to have, you have the arc and RAM, and then you have the L2 arc or whatever. You have NVMe, SSD, fast hard drives, slow hard drives, etc. Being able to do that all as one pool instead of separate pools, the whole point of ZFS was having one big pool with all your storage, and it just works well. Well, if you have to mix types of hard drives, then
But now do so many different types of storage.
and you need certain things need a faster one, and certain ones need a bigger one, and you can't have big and fast and cheap. Yeah, it's just a preference that it goes there, not a requirement. But you'll probably notice when all of a sudden the thing that used to be fast isn't fast anymore. And you'll need some kind of monitoring.
There's a real problem at the moment, though. We're not passing the mic.
Yes. Sorry. Person in front here had a question?
The device latency is going to cause technological conditions.
What's the question?
Device latencies, are they going to cause pathological conditions?
Which you mean like mixing SSDs and hard drives in one pool?
That's where
The question was, now that we can have metadata on separate devices and mixed devices, will the differences in latency between devices cause a problem? Isn't that part of why you have VDEV properties to say this disk is fast, this disk is slow? Isn't what that will work on?
Yeah, so part of the point of the special VDEVs is to take advantage of the fact that SSDs are lower latency. And generally in ZFS, you can't read the data until you've read the metadata to know where the data is. So you solve the pathology of that random reads on spinning hard drives are slow by using SSDs. I don't think it'll really cause any problems by the fact that some of the drives are faster isn't going to be any worse than using all slow drives.
None of drives actually guarantee much of latencies on access. Some IOs faster, some slower. I don't think it changes much to worst side. Of course, if somebody doing some benchmarking and may get some unusual behavior. If he's benchmarking slow IOs, it will, or small IOs, it will go to one VDEV, bigger IO to another VDEV. Numbers will be different. It will be some headache in production. That's a goal to make it work.
Yeah. Some of it being faster is better than all of it being slow.
I would just like to add one more feature added recently to the point of several, having one pool instead of several and having multiple VDEVs in one, is that recently significantly was improved pool import process, and now it's possible to import pool without some top-level VDEVs. And what it gives us is gives more chance to use number of copies attribute. So for most critical data, it's possible to set number of copies to 2, and ZFS will do additional mirroring of those data. So even for non-redundant, single non-redundant pool, it's possible to get redundant data. And while previously that mechanism also existed, but loss of single disk effectively would destroy the pool. It's no longer the case. Inheritance should be in stable 11 already, so yeah, it should be much more resilient and universal from that point.
Yeah, so with that work, if you had a pool and when you tried to import it, it crashed, it improved that a bit by just cleaning up the code. But the other part was, yes, even if you're missing an entire VDEV, you can still import the pool read-only and read whatever data is readable. Depending on the layout of your pool, that might be nothing. But importantly, if you're one of the people that has accidentally added a pair of SSDs as individual stripes instead of a mirror or instead of a log or cache device, and then didn't know to not just remove them and then try again, and then you couldn't import your pool, and while the missing VDEV only contained 100 kilobytes of data, the fact that it was missing meant you couldn't import the pool, you're now saved by that. And we have the VDEV removal stuff from a year ago or so.
Less spring case.
Yeah, so that you can actually remove non-redundant VDEVs from a pool by moving the data somewhere else. That's helped a bit too.
What's that new feature called?
VDEV evac. Oh, that one is just safer import, right?
There were several commits.
Yeah.
It's not exactly a feature.
Yeah.
Just more robustly implemented.
Yeah. So the import process is less likely to panic, and it's if you set it to read only, it will try a lot harder to give you something instead of just saying your pool is broken. It'll say it's broken, but maybe you can get something out of it.
All metadata in ZFS are always duplicated.
Yeah.
There are at least 2 copies, sometimes even 3 copies of metadata. So if you're losing single top-level VDEV, you'll still be able to import pool, see data sets, directories, files, access to files. It's probably will be a problem, especially for big files. But if for important data you set copies set equal to, you will be able to still access the data.
Yeah, so each block on ZFS, in the block pointer, there's 3 slots for where it is on disk. By default, for pool-wide data, it's 3 copies. For just metadata, it's 2 copies. And regular data is 1 copy. But if you set copies equals 2, it'll try to write your data to 2 different places on disk. And it tries to make those not the same disk. So if one goes away, there's still another copy of it. Is there any other interesting stuff from the Dev Summit?
Question in the back.
Oh, Nick again.
So if I were to use like some really cool NVMe drive, or probably 2 drives, for my metadata, and I turn on dedupe now, do we think that will, what percentage of the problems with dedupe will that solve, do you think?
None. So even if you make them the dedicated dedupe type, dedupe still has all the same problems of every time you add something to the dedupe table, you have to write out the dedupe table and it gets big. Okay, so the question was about if you use the dedicated devices for dedupe table, whether it makes dedupe usable or safe, and I really don't think so. At the ZFS Developer Summit in 2017, Matt Ahrens proposed a way to rewrite dedupe so that it wouldn't be terrible, and somebody just has to do that. And then it won't take as much memory, and in particular, every time you write, like the idea behind dedupe is if you write data you've already written, ZFS notices that and doesn't have to do anything, except for it still has to update the dedupe table to say that you wrote some data and then write 3 copies of that. And so you end up doing more writes than you saved yourself from doing. And you still have to try to fit that whole dedupe table in memory. Whereas with Matt's proposal where it becomes a log of, you have the dedupe table and then you have a log saying, increase this hash by 1, decrease this hash by 1, etc. Then you don't need as much stuff all at once.
That's not quite.
Right, okay.
What it does is when you fill up your dedupe table, the system doesn't break.
Right, so there's another feature, another part of the plan where you set a maximum size for the dedupe table, and when you reach that, when you want to do an insert, you find some hash that only has 1 reference and kick it out to make room for the new one. The idea is that when you go to delete a file, normally you look at the dedupe table and see if there's more than 1 use of it, then you don't do anything. And if it's the last use, then you can free the blocks. If you kick out an entry that only has 1 use, when you go to delete that file, if you don't find it in the dedupe table, it's because you kicked it out of the list to make room for somebody else, and you can free it. If the same block comes in again, you end up not deduping it because it wasn't in the table and you re-add it. But basically, if your dedupe table's full, it's probably because the blocks that only have 1 reference have not deduped. And so kicking them out and maybe letting some other file have a chance of deduping, basically it's the dedupe ceiling. It lets you have some dedupe, but give up before it bogs your machine down. And hopefully you end up only deduping blocks that are only spending memory on deduping blocks that are actually deduping multiple times, instead of a bunch of blocks that happen to be unique and are just taking up memory and not giving you any win.
With ZFS coming to Linux, have you seen less users switch over to FreeBSD? And with that, and also with ZFS being ported over to Windows, do you think there'll even be less of an opportunity of users to convert over to FreeBSD?
My view on ZFS becoming, with ZFS becoming available on Linux, are we seeing fewer people switching over to FreeBSD? So I'll answer that one.
And now that it's coming over to Windows as well.
And now that it's on Windows, my feeling on that, and when I first heard it was coming on Linux, said, holy shit, they're going to get a decent file system after all these years. Seriously, I think it's the best thing that's ever happened for ZFS and for any other operating system to be able to get it, because from a system administrator's point of view, it just makes my life so much easier, both from administering the disk and backups and controlling stuff and copying stuff over. It just makes a whole lot of other stuff so much easier. And the goal of having ZFS on FreeBSD was not to attract more people. And if they come anyway, that's fine. If they don't, that's fine too. But I'm just glad that they get a decent file system.
So my opinion is also very similar, that we never had like multi-platform file system, decent file system. The FAT was the only choice, right? And it was like extremely simple. So being able to have like the best file system there is on multiple platforms is, I fully agree, is like the best thing that ever happened to operating systems, I guess. And OpenZFS, that was the idea behind OpenZFS. It was open from almost very beginning. So I'm also really glad for the same reasons. We have some very rare, but sometimes we do have to use Linux, and I would love to be able to just use one backup solution for all our servers, all our applications and stuff like that.
Do you have any opinions on that? Almost.
On that one question, you get them all?
Yeah. So OpenZFS being available on Linux, FreeBSD, Illumos and Solaris and Windows and Mac, and NetBSD now. OpenBSD is the only thing that's not going to have ZFS left. It's very useful, and it's great. And if we can keep the interoperability, that makes it super useful. I do believe it means FreeBSD maybe needs to do a little more work to make the integration better and make the ZFS experience even better on FreeBSD than what's available elsewhere. But I think that's an opportunity for FreeBSD rather than, we were only going to get ZFS to ourselves for so long. And we never really had it to ourselves. Illumos always was the source for it. And then, it's existed for Mac for a long time. But Windows getting it was a real surprise last year when we saw that live demo. Like, hey, you did what now? But it's getting better, and I'm glad that that exists. And yes, it was too good not to share.
I've got a slightly different take on platform switching, just because people and organizations don't use operating systems. We use applications that run on operating systems. I know someone who has seen a shiny silver disk labeled Oracle for FreeBSD. And you could only get it with like death threats and having someone's children locked in a basement, and by writing a check to Oracle. So people are using an application. If we want to propel people to FreeBSD or BSD in general, that means applications running on your operating system. I take a lot of crap because I have a Windows laptop, and I have that because I need Adobe InDesign. And with the first open source BSD that gets Adobe working with correct color resolution has my loyalty. So the file system does not attract people, the applications do.
And that's why last week I agreed to start mentoring a Postgres developer as a FreeBSD source developer to improve the integration of Postgres with FreeBSD and ZFS. Because that's how we're going to get the users, by having better performance of Postgres on ZFS on FreeBSD than on Linux, not just by having ZFS itself.
So one last note. So I think that the challenge now would be to actually convince Linux to keep this interoperability all the time, because of course unfortunately they tend to do things on their own, so it's sometimes challenging, but I hope that as long as ZFS is under OpenZFS organization, let's say, it will happen. It will be really a thing that you will be able to switch between operating systems and have the same ZFS and share the data. So I think that would be the biggest challenge, but definitely we want ZFS to be as available as possible.
Yes, and to that end, out of the the ZFS Developer Summit about a month ago, we've started having a monthly call with the ZFS stakeholders from all the projects as part of OpenZFS to try to make sure that the Linux people don't go off the rails. So there's a monthly call with Mav and myself and a bunch of people from FreeBSD. You should come if you have time. And the Illumos people and the Linux people and so on. And we try to make sure that all the features end up in all of the versions of OpenZFS and coordinating so that at least we know who from FreeBSD is working on porting the crypto and who on FreeBSD is working on porting the multi-mount protection feature and so on. And the video is available for anyone to watch after as well. So if it was Tuesday before last. But if you check out OpenZFS on Twitter, they have the video as well.
So just wanted to remind you to bring up what we discussed. Is the Behlendorf is actually much more amenable to timely acceptance of contributions than the Lumos
Yes.
was.
But
Is also quite receptive to upstreaming FreeBSD support properly. So the goal will no longer will be a bit of a misnomer.
yeah. So yes, as Matt was pointing out there, the ZFS on Linux project has always been much more open to contributions and had less requirements of rigor than getting things into Illumos. For good and bad, yes.
We made a lot more progress, and there are lots of bugs fixed in Zoll, and there are real serious problems that exist in Illumos because by relative terms, we've only run it on toy systems. I mean, like certain things that will lock, they don't have certain functions because they'll lock up if you try to initialize multiple tools at once. So, I mean, let's be honest.
Right. But importantly, Brian Behlendorf, that's leading the ZFS on Linux project, is very amenable to letting us actually put if-def FreeBSD stuff up into the repo and do the same thing. We try to convince all of vendors that use us as an upstream to push the stuff upstream and have it maintainable there and testable there, and not just have to have our own local modifications for everything. And so I think that. Yes, the reason we have this call now is to try to make sure that we can communicate with the Linux and the rest of the OpenZFS community and keep everybody on the same page and make everybody work together well. And I think it'll work out better for everyone that way.
Thank you.
Yeah.
This gentleman back here is the main one.
Yes, he points out now once we get the ZFS native crypto ported, there will be a common crypto encrypted file system available across all those platforms, including Windows and Mac and so on. And that's very useful as well, especially if you just external hard drive that's encrypted that you can just plug into any computer and be able to mount is something that just doesn't exist today.
There's a question from Twitter to that point, and we have the developer in the room. Can we get an update on the native encryption for FreeBSD and your porting list? Is anyone there?
Yes.
Yes.
Twitter, yes.
Yeah, right. Land me your microphone.
Well, you've got the recording mic. You've got the magic microphone. He needs all the mics.
Let's talk about the door.
Okay, so the status of the encryption is IX hired Matt Macy to go over my code because I'd missed a reference count somewhere and could not find it. Something about being bogged down in 30,000 lines of changes for several months makes you blind. So he fixed it. He's got it up on a branch. He put it up for review. It's doing pretty well. I've been doing occasional trying to stress testing it and performance analysis. Performance is so far, let's see, on a single disk system, it is slower than Jelly. On a multi-disk, such as mirroring or RAID, it's can be a bit faster to sometimes very much faster. You have to make sure you load AES-NI or it is so slow. And Matt is planning on integrating it in as soon as the code unfreeze. Any questions on that?
Yeah.
There's there's questions here and there, and there's some other.
Okay, well, pick someone. I can't see him.
Is the OpenZFS crypto receiving any formal crypto verification from standards bodies?
No, and it is horribly insecure in many ways because of the decisions made. The crypto code itself is fine. It's just that when I'm blanking on his name, implemented it. Thank you. I always mispronounce his name as Tom Capaluti for some reason. Anyway, when he implemented it, he did a couple of things that I don't necessarily agree with, namely deduplication is done before encryption instead of after. And there's another thing about sparse files that I don't like, but all the crypto people tells me I'm too paranoid, which is weird.
John Mark, did you blow a gasket?
Yeah, well, basically the fact that the file system data is not authenticated, there is no master key that authenticates the user block from being modified. Basically, it means that the key is not very useful. So there would be another layer of authentication/encryption.
Well, the code right now is not really intended to encrypt an entire pool, and I haven't tested that. The big win for it is always going to be that you can encrypt specific data sets, not the entire pool. If you want to encrypt the entire pool, I would recommend going with Jelly or with one of the secure encrypted drives because the overhead is going to be less for the latter.
The authentication could be probably a separate step, like probably independent from the encryption. You could use separate key, pool-wise separate key to authenticate the user one because you have variable tree, so it's actually ideal to be able to authenticate. We already do that with SHA.
Yeah.
But it's like a HMAC.
Correct.
So it's the missing piece, right? But
Yeah.
I wouldn't particularly like. I would treat those two subjects as separate. Right?
Yes.
And especially if authentication is extremely interesting subject in storage because I did that for Jelly. I did authentication for Jelly, but it's not really practical. Especially, it was more practical when the disk had smaller sector sizes. Now with 4K sector sizes, it's impractical. And so I would really love to see like being able to authenticate the data in ZFS, like be able to do HMAC or the but that would be great. That's something that is missing in the whole industry actually, so that would be great.
Yes.
Yes, John.
So you're talking about cross-platform compatibility. One platform that we didn't mention in that list. How do you feel about APFS? Was there some kind of missed opportunity there?
So there is OpenZFS on OS 10. So you can run OpenZFS on OS 10, but it's not the native. Apple doesn't ship it natively.
You need, I don't know which is which. The later's recording. Okay.
There are many rumors about why ZFS was ported to OS 10 by Apple but never shipped. And it was either because Oracle or it was because Scott McNealy announced it the day before Steve Jobs was going to announce it, and he decided that wasn't fair. And threw it all in the garbage.
APFS, Apple is not even shipping specifications for it.
Yeah, they claim APFS might be open source someday, but it only does checksums on the metadata, so I don't want it.
But now that we have ZFS and it's mature, you really need to have like strong motivation to port APFS to other platforms, right?
Porting APFS, I was kind of saying, do people feel a little bit sad about the fact that dtrace was really close to being something that would ship by default on other major platforms? ZFS. I did say dtrace. Sorry, I meant the other Solaris.
You did hear that dtrace was ported to Windows, though, right?
Yes. Yes.
There's video and everything. So ported by Microsoft to Windows.
So there's a question over here somewhere.
The person in the green shirt had a question at some point, but has given up on us.
So along that line,
the panel think about Dexter's suggestion earlier that maybe a lightweight ZFS that would ultimately stream into Android as a deployment?
I heard rumors that Samsung got ZFS working on a phone at some point, but then didn't ship it. I don't know how much. I feel like it would be a lot of work to get ZFS to work on small memory systems. Although phones aren't really small memory systems anymore either, so.
On the other hand, if there was a lightweight ZFS, particularly if it could, that implementation could move away from CDPL, then they would get OpenBSD to use it.
There was at some point lightweight ZFS implementation, like all the structures were smaller and stuff like that, and it was less memory hungry, let's say. But I'm not sure it was ever like production quality or ever finished. But definitely there was some try. There was some take on that.
And I'm going to throw out patience. When ZFS was first introduced, you could really only use it on high-end systems. As I recall, OpenSolaris in the 200 somethings shipped with a lot of things like checksums disabled because the system didn't have the performance. At least every OpenSolaris system I stumbled across had checksums disabled. So 10 years from now, I suspect that phones will have the capacity of my laptop today and be just fine running full weight OpenZFS.
I got one last thing on that, and then we'll go to another question. You were talking about speed. Oh yeah, speed is one of the reasons why we now prefer compression in the file system over dedupe, because you get faster throughput overall. Question over there.
Yeah, just a minute ago, Pablo, you were saying something about something not being feasible because of 4K, because of the larger blocks.
Authenticating the data in each sector.
Authenticating the data in each sector is not feasible because of 4K blocks.
So, so basically, how Jelly I'm not sure if you want to hear about Jelly, if this is ZFS panel, but I will try to be quick. So the idea behind authentication, data authentication in Jelly was that if you have 512 byte sector, what we would do is to take 9 sectors like that and combine them in one 4K sector. So basically, we lose one sector for each 4K, right? So, and we will put this authentication data actually in each 512 byte sector, and basically, when we sum up, we will get 4K sector. It's still a bit. There could be a race, especially with UFS, which requires that if the drive says that the sector size is 4K, it is atomic. It has to be right. It has to be atomic. It's not a problem for ZFS, but for UFS it is a problem. But now that you have 4K native sectors, you don't want to combine like 9 4K sectors and get 64.
We actually had something very similar. It wasn't in terms of authentication and checksums. It was in terms of basically parity and basically doing a RAID 5 across sectors. The original implementation was exactly as you said, 8 sectors plus 1 sector of parity, and so since our file system did everything in terms of 4 kilobyte blocks anyway, that works out fine. You write 8 5 kilobyte sectors, that's 4K, and it also does this other sector of parity. When we moved to 4K drives, one of the things that we did, actually before we moved to 4K drives, is we ended up changing the parity ratio. Instead of 8 plus 1, we actually made it 32 plus 1, and we figured out that still gave us all the bit route protection that we needed, but at a much lower space overall.
Yes, not sure if I will be able to repeat that, but basically when you go to 4K sectors, you changed from 8+1 to 32+1, right? And but with general purpose file system, you cannot actually go above page size because then your mmap and stuff will stop working. So actually 4K sector is pretty much the maximum you can do if your page size is 4K.
John Mark?
So this is for anybody, but Alan, you mentioned mentoring a PostgreSQL developer. Is there any thoughts on exposing PostgreSQL specifically for ZFS such that you can just be able to close details and run an issue?
Right. Yeah, so the question is about, specifically in this case for Postgres, but anything using, so ZFS is an object store, and then on top of that, you have the ZPL, the ZFS POSIX layer that implements a file system. That's technically optional. You could actually use ZFS as the object store to store objects. And that's what actually the ZFS on Linux project, the government lab behind that, Lawrence Livermore National Labs, is actually doing that with LusterFS. So they're not using the POSIX file system, they're using Luster as a clustered file system and writing objects across a whole bunch of separate machines that are separate pools. So theoretically, yes. I'm not entirely sure how you would expose that interface to user space for Postgres. But yes, you could take a Postgres storage engine type thing that would talk directly to ZFS and know ZFS semantics and be able to optimize things. But I don't know anyone who's actually doing that work right now. But it's definitely very interesting. Although the person who would do it would have an interesting intersection of skills.
It's also a matter of
Did you have something?
Separate objects, which cascades into multiple writes on both sides. So by being able to expose the log structuredness directly to PostgreSQL, you can effectively merge the two together, and you basically end up with like half the number of writes for PostgreSQL.
So basically you are saying that you could use ZFS transactional semantics, yes, to use directly in Postgres.
Hammer file system actually exposes an object to API IC files. Yeah. So the big advantage is that you can say start a transaction, write these objects, commit the transaction, and so you get the log structuredness that Postgres needs in order to guarantee consistency, and then you don't have to deal with the to write commits that PostgreSQL does already.
You want to repeat that? You want to repeat that?
So John's point was to use the transactional nature of ZFS to replace the extra work that Postgres is doing, where it writes to a write-ahead log and then eventually flushes it out. And just since ZFS provides all those same features, if you could just say, hey, data store, I would like to write all this stuff down. And then sync it, please, then you would, Postgres would stop asking the file system to do a bunch of extra work for no reason. Yeah, if there was a POSIX interface for object storage. Yeah. Mm-hmm. Yeah, although one of the options, instead of having an interface that's more file system-y, would be just having Postgres talk directly to the data management unit of ZFS and just be like, here's some memory, fill it with stuff, and then give it back to me and I'll write it out for you and guarantee that it's safe, whether that's buffering it through the ZIL first or putting it directly on disk or whatever.
Not quite yet. So, so to some extent, you could use zvols basically to this to bypass ZPL layer, and actually you can also use ioctl to send bioflash to zvol, which will basically call zil commit. So, in some way, you could do that, but probably you want tighter integration with DMU. Yes, that's true. But that would be actually, of course, it might be tricky. So I don't want to invent it on the go. But I think it would be in theory possible to have like octals that will start and finish transaction in ZFS. But of course, you want to make sure that the transaction will finish even if Postgres will crash or something like that. So.
If you get something, you got it.
No, I would just like to say that to provide that kind of atomicity, all the writes within transaction group should be within, like, not literally within transaction group, but within one ZFS transaction. Which means if it's not closed in time, ZFS will stuck after like 5 seconds later trying to close that transaction group, or it will not continue. So from inside kernel it could be done, but there is no user space APIs for that, obviously.
I'm not dead yet. Is there another question? Because if there isn't, I have a question. Alan will figure out why I'm asking this just as soon as he hears it. Is anyone using Micron 5100 SSDs with ZFS? Bugger. I may be the first then. So, yeah, but we weren't. Sean Bruno? Yeah, Sean said that he was using them, but we haven't been able to verify that they were used with ZFS. We were this close to ordering a machine with 24 of those SSDs, and if you don't know what they are, they're 4.5 terabyte SSDs. And we had this sudden thought, oh, is anyone using these for ZFS? Because that's actually what Alan asked. And so we said, oh, good point. Maybe we'll only order 2 of them for now, and then we'll see if it works. So hopefully that'll be back in the office in a week or 2 and we can start playing with it. But we're going to use it for backups.
The real hitch there is this the 4.5 terabyte or the 7.5 terabyte?
I think they're 7.5.
Yeah, so they're 7.5 terabyte SATA SSDs, but what makes them special is in order to get that size cheaply, it has a 16 kilobyte sector size, which is beyond what the Uber block can't be larger than 8 kilobytes in ZFS. So the max A shift is 13. Yeah. Yeah, the 5100, only the very largest size has the bigger sectors. The 7.5 terabyte one. You can go up to, I think, the 1900 gigabyte one is still 4K sectors.
So if you have a few sitting around.
Oh, no. I've gone up to the 1.92.
Okay. But yeah, the 4 terabyte one is 8K sectors, and the 7.5 terabyte one is 16K sectors.
I know that SAS allows up to that sector size.
They're SATA, not SAS.
Oh, these are SATA?
Yes. Yeah.
Yeah, so SATA, I guess technically it does let you do an arbitrary power of 2.
Yeah.
So that way. And the SATA code in the driver does recognize it, and so it should expose it.
Yeah. And then ZFS is like, you can't do that. So the in the label, the 128K we have for the Uber blocks is, and we do the ring of them, but the code just literally does, you can't go over 8K. It'll say no.
Well, if I remember correctly, on A shift size, we should support A shift up to 16K. So, but
not for the Uber block though.
Maybe it's just 1K.
So it'll only be an issue if the drive reports
Well, it's, in particular, it'll only be an issue if the drive will not accept a write smaller than 16K.
Right, so it could be,
If it's emulated, it'll be fine.
yeah, it could be doing 16K native 4K.
Yeah.
Because no one's ready for it.
When you get these drives, do me a favor, do camp control identifying.
But yeah, so like most 4K sector drives you buy are 4K, but they can emulate 512 byte. So if you write 512 bytes to it, it'll read the 4K, modify the 512, and write it out. If it does that, it'll work. But if you have a 4K native drive, if you try to write just 512 bytes to it, it gives you an error saying that's not a whole sector. You can't do that. And if this one does that, then it might have some problems. I have some ideas on how to fix that in ZFS, and I just have to get around to it. So I might have to buy a pair of them as well. You could cheat it with GNOT probably, yeah.
Yeah.
But you don't want to have to do that. I've only ever done GNOT to lie to ZFS to make it bigger, not to try to make it smaller.
We have to do it modified then.
Yeah. Does GNOT actually, would it be able to break up or like aggregate writes like that?
Let's find out.
Yeah, only in the other direction. Yeah, it only makes it bigger. It can't make them smaller. Okay.
You also use GNOT to emulate a very slow device.
Yep.
Anyway.
That was fine.
Thanks. Mine was the last question.
We probably have time for one more. Yeah.
Here's a question with all these new features. Is it time for us to do a second edition?
Probably. I'd like to finish some of the features I have in progress first, but
Okay.
but then I will just keep inventing more features. So at some point we do have to just do a second edition of the book.
Okay.
Time-based releases.
Can you do that for books?
5 minutes ago.
But they understood the closing is much shorter than the time slot, so we can go over. Yeah.
There's one follow-up question to the crypto question. Are there any barriers to using every available on-CPU crypto acceleration method via SHA or AES on Intel, on AMD, on ARM64?
That's mostly a function of the crypto framework in the kernel, right?
That is the reason why I made it work with OCF as opposed to using the ICP, is so that it could use the various device drivers that FreeBSD supports.
Yeah, so what Sean said was that when he ported the Linux code over to FreeBSD, he made it use FreeBSD's OpenCrypto kernel framework instead of on Linux. What they did is port the Illumos kernel crypto framework. But this way, it can take advantage of the AES and I code that John Mark and other people already had created, and we'll do. Do we have anything for the SHA in the kernel yet? Yes.
Yes, we do.
For the actual instruction. Like the specific. Okay.
So
Okay.
it's nice supported.
Yes, okay. So there's that, and then on Linux they have support for the Quick Assist offload, and our OCF will have that pretty soon. So we'll be able to take advantage of that, which will accelerate gzip compression in ZFS. Although I think Z standard will work out even better. So, but having an option of gzip where it doesn't use the CPU, it sends it off to an offload card, or Quick Assist is starting to be integrated in motherboards and so on now as well. Could make things get really interesting.
Like the number of Atom processors have it on the Raspberry.
Yeah, a lot of Atom processors and the Xeon-Ds have integrated different size Quick Assist cards now. Although, if your sectors, if the amount of data you're gzipping is under or not significantly more than 4 kilobytes, it usually takes longer to send it out to Quick Assist and get it back than to have just done it on the CPU. So probably not a win for databases, but for other workloads where you're using gzip, it can actually be a big win.
I tried to experiment with some QET cards with very basic experiments, but I found the same, that in many cases use SNI just on CPU. It's much faster than try to push them for offload. Maybe for some network traffic when you could do some huge batching, it should not be a problem, but for storage, when you quite often have very small queue depths, that may be very significant. On the other side, comparing to Jelly, when Jelly always use fixed like 4K block size, and it's huge overhead for external crypto accelerators, ZFS crypto should benefit a lot from using bigger blocks,
right,
and potentially
you might send the whole 128K off to the crypto card at once.
But for me, it's really, because we did experiments as well, and for symmetric crypto, if you use AES-NI is just the best. It's really, for me, it's really hard to imagine that you want to go through PCI because you want to use it for other purposes. So I would definitely stick to AES-NI, but QAT is good for like asymmetric crypto, of course, and so, but maybe for compression as well, especially gzip, which is pretty intensive. But
Any other questions?
I have an answer for a question that you've all been wondering. Yes, that string is attached to a balloon resting on the ceiling. I have a photo I'll post to Twitter later if you don't want to come up and look.
Happy face, yellow balloon.
I'm glad we got that sorted out. It's been bothering me.
by the way, if you use AES-NI, you might want to turn on hyper-threading, because actually it gets twice as fast with hyper-threading. So.
Question for the audience. What's the #1 barrier preventing you from using the ZFS on your desktop or solution?
Nothing, I use it.
Incorrect pronunciation.
Nothing.
But we're all correct, and you're wrong.
Yeah, the large memory requirements because for like ARM64 boards and other stuff.
But ARM64 boards can have more memory.
Yeah, it depends upon what you have. Like,
How much memory are you talking about here? Because I've got an 8-bit box running ZFS.
well, like the A64 LTS.
But we also don't have ECC, so what's the point?
That is another good point. Well, good environments, though.
Yeah. Generally, the memory usage mostly comes down to your working set. So if you're, as long as you're not using too much data, as long as you're not using too much of your data at once, it'll work fine. Peter?
The reason why we never actually deployed it at work at former company was the uncomfortable relationship between Arc and the VM system. So we had a lot of heavy use of the VM system, and the relationship just wasn't comfortable. It did not play fair.
Yes. Mark's going to fix that for us, right? He kind of waved. He's hoping to fix that, and that'll get better.
VM was the one thing I didn't want it to touch. So.
I completely understand, but that was why we never actually got to the.
But that's good reason, yeah.
Because I'd also like to get send file to work nicely with ZFS, because ZFS has a mechanism to lend ARC buffers out so that you could use it with send file. It just needs a bunch of plumbing first.
But ARC buffers are now compressed.
Well, it would do the DMU buffer, the uncompressed one. It's smart enough.
Slightly, yeah.
Yeah.
You bought one copy out of 2.
Yeah, it wouldn't quite be 0 copy, I suppose, at that point. Although if you're using it for that work case, you could disable compressed ARC.
Oh, yeah, if you're broadcasting videos, sure.
Yeah.
As a follow-on, unprivileged send file, would there be a possibility for doing scatter gather in replication so you don't have to issue a serial stream?
Can someone first explain to me what that means?
Sure.
No, Alan will.
I'm not sure what he's getting at. So in the ARC, we have ABD now, ARC buff data, where memory allocations are scatter gather of 4K pages instead of doing like 128K or 1 megabyte contiguous allocations for everything. But what do you mean about for replication?
Rather than having to serialize via ZFS send, if you could expose the scatter gather interface to an intermediate replication agent, that would allow TCP stream parallelism and then rely on the receiver to gather those transactions and resequence them in an ordered manner.
So a different interface for ZFS send receive so that you could do multiple streams.
You don't have to push it through a pipe.
Right, so that you're not pushing it through a pipe and turning it into a single stream so that you can, yeah, just send multiple data sets concurrently. Yes, Ravi.
Actually, go back there a second or hand up for.
Oh, yes. Every time we look at them, they hide. Who had the question over here? Somebody back there. Oh, wait, oh, okay. There you go. So the question about how feasible is doing ZFS on root on a Mac. The way the OpenZFS or OpenZFS on OS X developer described it to me is you do a ZVol with an HFS file system on it, and then you somehow bootstrap into that. So that has been done. I don't know about activating all of a Mac on ZFS. That might be complicated. Yeah.
Weird things happen with like fonts because there's old crusty type integration of metadata on HFS that works weird.
Yeah, they use resource forks on a Mac to store information about fonts, and ZFS, it would just be weird.
So, now, since after him, I want to actually give my answer to why we don't use ZFS. It's kind of a niche thing, but mutable snapshots.
What do you mean by mutable snapshots? Isn't that what a clone is?
No, this is you have an entire snapshot, and you need to remove a file and the entire history of that file, remove it from this file system over here, and put it on this other VFS file system on this other system over here, so that if you refer to a given snapshot somewhere in history on this first system, that file is buried. And when you look at that snapshot on this system over here, the file is there. Unfortunately, this requires a full block pointer rewrite.
I definitely have yeah, there's definitely been times where I wish I could delete just one file all the way back through snapshots.
That's exactly it.
Sometimes you're legally required to remove all copies of it.
Yes, and so Sean pointed out that sometimes you're legally required to move copies of a file, and that's one of the cases where when you have to actually destroy all possible copies. That's one of the cases for the encryption, native encryption support, is having a data set where you can throw away the key and know that it's all destroyed, whereas because of copy on write, you know that there's no unencrypted copy laying around somewhere else on the disk that you can't, that's just not hooked up or whatever. So yes, punching holes in snapshots would be interesting, but I don't know that it would be possible.
It's a particular case of block pointer
Yeah.
rewrite or these basically rewriting.
Yes. Redacted send almost maybe could make that case work, but it would really, you'd have to send the whole stream and receive it again with just filtering out that one file, and that's a bit extreme. You wouldn't want to build a product that does that. All right.
Couldn't you just delete the blocks all the way down the pointers, and then instead of it coming up with...
Because you would change every one of those pointers.
No, don't.
Okay.
Just delete the data blocks, and then put a separate file metadata to let you know that that should be gone. That you actively are aware that metadata is gone with the second log.
You will override the data. Override the data with some random.
Yeah.
Checksums won't much, and you won't be able to read it.
Yeah. So just mark it as free in the space map and let you overwrite it.
Yeah.
Hope for the best.
I understand the use case for wanting to delete it, but I understand the bigger use case of snapshots which are immutable, which is the whole idea of snapshots. So all I can think of is you need something other than snapshots to do what you want to do.
Right. So what for us ultimately came down to either our own file system, our own lowest level file system, which is what we have done to date and what we currently have, And for our next-gen product, it is actually this particular layer of this architecture will be based on Butter.
Who are you again? Like what? Which company? Because not everyone knows. Yeah.
Anybody else? Going once. Twice.
Okay, thank you, everybody. And thank you to all of you for being on the panel. What's that? Oh.
Pick up the damn book, okay. No,
Where can we buy them?
There are
Amazon.
books on ZFS.